Good evening, very good evening. Assalamu alaikum. This is Jakir from Dhaka, Bangladesh. Due to technical problem, we are here. The water chemistry live group we are having in on JTZ, our distributor group and distributor page. So thank you. Sorry for the late. This is 10:45 here. So we are discussing water chemistry continuously from the starting of the lockdown. Today is day 41. And I'm really appreciate but apologize that due to some technical problem on my Facebook account, I have to work on different account. So many of you regular participant are miss me, and I'm sure that is all right. But still, I like to record it and I like to share on YouTube so that you can view it on different places. Thank you very much. Welcome. So we are discuss water chemistry today. We like to discuss the organism and last part the control the chemistry. So we discussed the internal water treatment. We classified them thank you Sharif, thank you very much, welcome. I'm late but I started on this JTZ Bakpan page because of the problem in my technical in my page and my Facebook group. So we are discussing regarding the biological corrosion and scaling problem. We finish scaling corrosion. We are discussing continuously the control of microorganism. Yesterday I have already discussed some part of the control, and we know the microorganism, especially we consider algae, bacteria, fungi, legionella. We discuss very detail on every aspect like algae, bacteria, fungi and legionella. Here we discuss the chemistry part, and today I like to contribute. I like to discuss the chemical part also. Sharif, thank you for joining. If you share with the other team member who can see and watch, welcome. Golam Kibriya, thank you very much. I'm sure you are doing good, family and everybody doing very good. So you can share on your wall so that the people who are missing can join and can see it. And because of technical reason, I also request you please share on the other group, on Bulab group and other groups, so that other people also can be connected. And right now from now on onward, until I am not get back the account and other pages will not active, so I will continue on JTZ Bachman group. So thank you very much. So we discussed yesterday the part and many days the different kind of bacteria, different group of bacteria, aerobic, anaerobic, aerobic, sulfur, SRB, different kind of bacteria. We discussed on detail. We discussed the metabolism, growth, requirement for any bacteria, all the things we discussed like sunlight, moisture, air, pH, temperature. We discussed a couple of times. We discuss again the different growth cycle dynamics of bacteria, lag phase, log phase, stationary phase and death phase. And important things to understand is that we have to control bacteria here, the lag phase. If we miss the lag phase and bacteria number grow here, it will be very difficult to control by chemically all the time. So thank you for your continuous support, and thank you, and definitely thank you Sharif, welcome. We discussed the legionella, the serious bacteria that is health related issues. If anybody, any human inhale this kind of bacteria due to the cooling water environment, cooling water mist, he might got a serious pneumonia. And if it is aged person like corona, he can get died, and so can create a lot of serious health issues. So we started to discussion control of organism activity. That is our today's discussion. Yesterday also we discussed different some part on class 40. We discussed yesterday that to control any organism or any this kind of problem in water, we have to work on different level of control, like strategic control, environmental control, physical cleaning and other strategy, and finally chemical control. Only chemical cannot always help all the time, so we have to be do all the four strategy. And if you see the strategic control part, what are the things that strategic control we have to do? We have to be very practical, we have to be very realistic. We have to understand cooling water treatment is not the water making fully hygiene like as a drinking water, because cooling water we never drink. So we have to be control at a certain level to killing the bacteria. We have to minimize the bacteria at a minimum level, but we don't like to, or we can't control bacteria at a zero level. So that's why we have to be very strategic. We have to be design our treatment all over the system, and it should be economic. We don't like to be sanitized or sterilized like a pharmaceutical medicine or like other things. And microbiological control based basically on the logic and common sense, because every site have different limitation, every site have different aspect, different environment, different pollutant, different production. So it's a totally site based materialistic things. We have to be very strategic to control this organism in that particular system. And during strategic control, that beyond many things, because of this bacteria, it go beyond our control. One of the major, some of the reason as per our experience is lack of awareness, lack of knowledge, lack of experience, and mostly people give lot of negligence for the very beginning of the new system. Once the bacteria is well controlled, they don't care, they neglect it, they ignore it repeatedly, and once become very thick layer, then it is a visible, and they like to now come and control. That basically is a become already out of control. So lack of flexible enough, because sometimes process contamination high, sometimes low, sometimes temperature high, sometimes temperature low, winter season, summer season. So depending on the season, chemical dosing and other strategy need to be adapted, to be changed. If we resist the same dose we do round the year, sometimes it not work. So that's why you have to be flexible enough. We should not reluctant to respond the changes. Like if system has some high turbidity, we must have to give the blowdown, we must give higher biodispersant, or we might to do something on the change. But if we don't respond, if we don't reluctant to respond, or if we think chemical consumption will go up and many things, then always there will be some problem and system will be under a biological problem. And many other problem is that blindly depend on the chemical and technology supplier. That is also another big strategic mistakes people do it, and then why the system become fouled and then become under control. Thank you, Mujumdar, thank you very much. So if you see the environmental control, definitely microbiological growth is fully depend on environment, depend on the carbon source, depend on the moisture, temperature, sunlight, and many other things. So we have to be very careful to control our environment. We have to be maintain the minimum level of favorable environment for bacteria, for algae, for fungi, and for other element like TSS, the oil grease contamination, the flow velocity. We must avoid the stagnant part and dead end part, so that we can be environment is very disfavorable to grow the microbiological problems. So if we can control environment in nice way, problem automatically will be less. And definitely we have to be control, understand the cleaning frequency, understand the point whether I can go for chemical treatment or chemical treatment will work, or I have to do for the cleaning, mechanical cleaning, offline cleaning. If my system microbiology already stand on a stationary phase, there is nothing will happen during the chemical. So you have to go for cleaning first you have to clean mechanically, then only chemical apply, then it will work. So you have to be very strategic during this graph, or during this curve. Where I am standing now, if my system is stand on stationary phase, then nothing will happen, only chemicals. We have to do some mechanical and other things. We have to change the physical flow and other things. And if we come on the chemical control, that is an important part. On chemical control, what we have to do, we have to be understand the mode of action of the different kind of biocide. Yesterday we discussed these things on the 40 class. So you can watch on this for detail. You can watch on day 40 class on YouTube channel. But I just recap it just for a couple of things. That mode of action is sometimes the bacteria is a cell, if you like the left side picture. So the bacteria, the biocide, they dissolve the cell. Biocide sometimes they break the cell. Biocide sometimes penetrate inside it. Sometimes they disturb to the nutrient part. So there are a lot of mechanism or mode of action they do in with the bacteria, and bacteria kill. And we discussed this yesterday in detail. I just give a wrap up. So sometimes some kind of biocide burn all over the surface area. Sometimes biocide put the negative charges all over the cell area. Sometimes biocide give destroy the metabolism system. Welcome Kamrul Bhai, thank you very much. We are discussing water chemistry here continuously. Today is day 41. Thank you very much. You can enjoy and you can watch our discussion. Thank you. Sometimes chemical destroy the enzyme activity and kill the bacteria, the structure, bacteria basement. Bacteria cannot support, and if they cannot support, like if people don't have home and don't have at least some shelter, some area where they can grow, they can sit down, they can stay, and they can reproduce. So similarly for bacteria, if some biocide, they destroy the enzyme, and the enzyme is not available, so bacteria cannot settle somewhere, cannot sit down somewhere, and they cannot go for their common other activities, and they cannot reproduce, and the number cannot grow much. So this is a different kind of activity that bacteria, that biocide work against the bacteria. And if you see the primary qualifying criteria for any product, as per the system demand, it should be broad spectrum. All the biocide and all the microorganism control chemicals should be broad spectrum. Broad spectrum means it should be cover all over different kind of major common bacteria. It should be work at optimum, at minimum doses. It should be biodegradable, means it should be environment friendly. It should work and flexible enough with the environment or the site environment, site other parameters like water chemistry. It should be working a wide range, like pH should be wide range, pH should be covered, and it should work at least a minimum at first quick action it should be happen. And depending on this activity and mode of action, if we see the chemical for the biocides, there are different kind of chemical that is applicable for controlling microorganism, and if we classify them as a broad, there is a two kind of category. One is a biocide and another is biostate. Biocide, basically they directly kill the bacteria. The chemistry they kill the bacteria, those are called biocide. And chemistry that does not kill but they inhibit the growth of the bacteria, inhibit the reproduction of the bacteria, that is called biostate. And the biocide is two kind. This is one of the oxidizing biocide, another is a non-oxidizing biocide. Commonly we see this oxidizing and non-oxidizing biocide. So today I like to get more time to discuss a few on the oxidizing and non-oxidizing biocide. If you see the trade name in the industry or in the market or in the other places, what the trade name is available, all this chemistry all together, the name is called biocide. It can be also called as microbiocide, it can be called microbicide, it can be called as algicide or algicide, it can be called slimicide. So all actually all this name, trade name is all are similar kind of activity, all are used to control the microorganism in any water body, especially in the cooling system. So if we want to see the important part, the options, what are the options or oxidizing biocide available, or what are the oxidizing biocide we can use in our system. We know that very commonly they use as chlorine, bromine, hypo, but chlorine, bromine, hypo all have some advantage and disadvantage. Chlorine commonly used for the bigger system like fertilizer. All the fertilizer plant they are using chlorine, and they sometimes the other industry they use chlorine bromine mix, sometimes they use bromine and hypo, some kind of industry they use only hypo, some kind of industry use bleaching powder. So there are a lot of options, but if you want to do chlorine, then chlorination you record a different setup for chlorination. We will discuss a bit on this maybe next class. And if you see the other more option, chlorine dioxide and ozone. So this chlorine dioxide and ozone usually produce at the site, at point at the plant. Even some area, some plant, they also produce hypo at a point at plant, and some area chlorine also can be produced at plant. So it can be both. We can produce some other plant, carry in the plant and dose for the system, or it can produce on site, means there is some generator, there is some plant that can produce chlorine gas, that can produce hypo. And definitely for chlorine dioxide and ozone, it is always at site generator. They always use this kind of, if you see the left side picture, we can discuss this on later when we discuss cooling water treatment. So this kind of special complex equipment is required to produce chlorine dioxide or to produce ozone. It is required electricity, so they consume electricity, and using some chemical reagents they produce chlorine dioxide. Similarly ozone can be generated at the site, but ozone is for use only for the small system, can use for ozone. Especially ozone is used for sanitizing for the drinking water plant. usually they use to kill any kind of bacteria if it is available. But for bigger system, it is not sometimes economically feasible to produce a capex, because all this require a capex, big capital investment. So sometimes it is not feasible for bigger system. And if you see, there is a lot of disadvantage for oxidizing biocide, especially if we want to use chlorine, hypo, bromine, this kind of oxidizing biocide. There is a lot of limitation and a lot of things that we have to be overcome. And the main important things, that one of the parameter, the pH is high. If the pH high, it become less effective. So usually if cooling water pH become higher, so all kind of chlorine and oxidizing biocide become less effective. If the above 8, the pH is more, then the effectiveness is get reduced drastically. So that's why as a oxidizing biocide using chlorine, we have to be very careful, we have to be very focused. The pH should be 8 or below 8, then it will be effective better. And even sunlight is a negative effect, means in presence of sunlight, if we dose this kind of oxidizing biocide, its requirement will high, it release in the air, it release as a without reacting with the organism, it can go out from the system. So it need more chemistry, more chemical amount if we want to dose at a sunlight time. So usually preferably for fertilizer, for bigger industry, because they need a lot of consumption, so they used to use without sunlight, either before sunrise or after sunset they use. So it is advisable to use without sunlight. And aeration reduction is the concentration. So definitely, because chlorination, we need to do dose and start a point where air contact is less. That's why all the time is a better dosing system. Put the chlorination pipeline to under or beneath of the cooling tower sink or cooling tower reservoir, so that they at least from the chlorination chamber, the chlorine distribution pipeline is maybe 2-3 feet below the water level. So that's why it can come out and it dissolve the water easily. It should not come out with the air very soon or very fast. So if it is the level of water over the chlorine distribution pipeline, then it will lose the air directly, and the requirement or the amount needed will be very high. So if you see it is a low pH create the chlorination. When dose the chlorination, pH reduce and it create the corrosion problem is high. So low pH activity. And as a disadvantage, that all this kind of chlorination chamber, the hypodosing system, the chlorine dioxide preparation on site, all are the costly setup, costly equipment. So for bigger system, you have a lot of capex need to be there, and this all are the hazardous chemistry. So handling, we need to be very high standard safety capex equipment. And the important thing also for the chlorine, there is a lot of demand. The chlorine only kill the bacteria when the system demand required. So system demand always varies, so dosing also vary. If you see the left side a table, every ppm of iron consume 0.6 ppm chlorine. Similar manganese 1.3, H2S 8, means 1 ppm H2S is present in the system, 8.3 ppm chlorine will consume by this. So that means to kill the bacteria, your available chlorine should be very high, dosing should be very high amount. And if it is a fertilizer plant, ammonia is there, every ppm of ammonia consume around 8 to 10 ppm of chlorine. So if ammonia is there, so the more ammonia, the more chlorine have to be dosed. And if we don't dose, the system will not clean, system will be dirty, and system will foul with the algae, fungi and the other things. So that's why demand varies with the different variation, different element present in the system. So if we don't meet the demand, this chlorine can't act and kill the bacteria, so bacteria will grow in the system. And this is all the chlorine, and this kind of gas is very dangerous to handle. So everywhere we have to be very careful. And chlorine is very dangerous if the chlorine gas leakage, and if any body exposed a longer time, he can die immediately, because it go inhale. If it is inhale and it goes to the lungs, and it just destroy the lungs. So that's why the lung should be we should be very careful handling this kind of equipment and this kind of dosing. and especially if you use hypo is a big quality issue, because with the time, every after month, hypo quality deteriorated by 50, 60, 70%. Means that if stock is old for the hypo is no free chlorine remain in the hypo, so it's become a very I say simply it's not a using purpose. It's not a effective one. It's just giving dosing, but no bacteria it can kill anymore any bacteria. So this is how there are some other more negative things, that if we use a long time oxidizing biocide without considering environmental aspect, if cooling tower structure is wooden, wood may be delignify and wood may be lose its strength, and anytime cooling tower structure may be fail, and sometimes many cooling tower structure fail because of the high dose of the chlorine. And definitely if we use pre-treatment in chlorine, sometimes excess chlorine damage the resin and RO membrane, and chlorine is very corrosive for any metal, any alloy, especially copper, and if it is a high level in any region, then stainless steel stress corrosion cracking also can be happen. So these are the very long list of disadvantages of chlorine, but still chlorine one of the cheapest economic option for many countries, where safety and other things is still not taken care very much seriously, and different project where many updated technology is difficult to arrange. So in that cases, chlorine also is a better option, but if we use chlorine, we have to be very careful to manage all this kind of limitation, and we have to be monitor all the limitation, and we have to apply the chemistry accordingly. And if you see the chlorine and bromine, there is a good chance of using bromine instead of chlorine, because if you see the graph, chlorine produce HOCl, and this is very much pH dependent. If pH goes above 8, then only 20% activities remain. Means we dose 100 ppm, only 20 ppm work, 80 ppm is a wastage. But if you dose the bromine and chlorine mix at that pH, cooling tower common pH at 8 pH, bromine remain 85%, almost 85% active. So that's why nowadays people avoid to use only chlorine. They use chlorine and bromine, especially the bigger plant, bigger fertilizer industry. They all use a mixer, chlorine and bromine, and that gives a better result. So that's why it is always advisable to choose the latest technology, better technology, rather choosing the traditional using technology. So bromine is a much better and much effective than chlorine. And if you see, there are a lot of other chemistry that we call non-oxidizing biocide, and non-oxidizing biocides are especially a lot of chemistry available as a non-oxidizing biocide. So we can classify non-oxidizing biocide as a two-part. One is called a metabolic poison, and other is called surface active agent. So if we like to understand both the point, there are a lot of chemical. There is a hundreds chemical in all the both category, and we will discuss very detailed tomorrow on this, and on the chemistry part. But today I just like to show how the two kind of bacteria work. If you see the metabolism or metabolic poison activity, the metabolic poison activity, they actually destroy the cytoplasm of the bacteria cell, and that is why that is a part of the metabolism of the bacteria, and that is why they call metabolism poison. And if you see the surface active bacteria, the biocide, the surface active biocide, they work around the surface of the cell, so that they can kill the bacteria very easily. They destroy the surface of the bacteria cell, and they kill the bacteria, and bacteria die. So this is how there is a two kind of special biocide that is available or used always. One called metabolic poison, another is surface active biocide. So we will discuss more detail on tomorrow on this. I like to close because it is 11:10 already. So guys, I think thank you very much who already joined. Due to technical problem, I lost my main page discussion, and that's why I come on another page, but still I like to continue your support. Once I get back my main account, I will come on that Water Chemistry Live. But all this lecture is available on Water TV YouTube channel, so whoever interested, you can download or you can read it over there. By the time, stay strong, stay safe, and thank you very much. Assalamu alaikum and good night. See you tomorrow 10:30 p.m. on JTJ Bachman Facebook page, Facebook account. Thank you very much. Assalamu alaikum. Good night. See you.